Now we discuss the questions 53, 54, 55 from the question paper of Engineering Service Examination 2024 Prelims DC circuits. And one more, this one is transients. Now we already did two. See the question. Thevenin equivalent circuit. Voltage resistance for the given circuit between terminals A and B respectively. What are the voltage and resistance across these two terminals by using Thevenin equivalent circuit? See, ఈ రెండింటి మధ్యలో థెవెనిన్ ఈక్వివలెంట్ సర్క్యూట్ అంటే రెసిస్టెన్స్ ఇన్ సిరీస్ విత్ వోల్టేజ్ సోర్స్. VTH కనుక్కోవాలంటే ఫస్ట్ ఇక్కడ రెండు సోర్సులు ఉన్నాయి చూసుకోండి, ఇదొక సోర్స్ ఇదొక సోర్స్. సో యూ బెటర్ టు యూజ్ సూపర్పొజిషన్. సూపర్పొజిషన్ అంటే ఒక సోర్స్ ఉంచాలి, ఇంకో సోర్స్ తీసేయాలి, ఈ సోర్స్ ఉంచాలి, తర్వాత ఈ సోర్స్ ఉంచుకోవాలి. ఫైనల్గా అకార్డింగ్ టు ద డైరెక్షన్ వాట్ ఈస్ ద వోల్టేజ్ బిట్వీన్ దిస్ టూ అనేది నువ్వు ఫైండ్ అవుట్ చేయాలా. సో ఫస్ట్ కరెంట్ సోర్స్ తీసేద్దాం. అంటే కరెంట్ సోర్స్ అయితే ఓపెన్ చేస్తాం కదా, ఉన్న సర్క్యూట్ గీయండి. ఇది ఏ బి. ఒకసారి మీరు చేసుకోండి, తర్వాత నా సొల్యూషన్ చూడండి. దట్ ఈస్ ద బెస్ట్ వే టు ప్రాక్టీస్. ఇప్పుడు ఇది ఓపెన్ చేసాం కదా, సో 16 ohm అనేది no way considered because no current flow in this, because this is open kada. So now these three are in parallel, so this is 24 volts. Then what is the current in this, and find the voltage. For that you have to find the voltage across this 5 ohms. Now current in this is 24 by 25 ampere. Now VAB dash, because we removed one source, that's why we called it as VAB dash. Now VAB dash current flow like this. The voltage drop across this one is this resistance into the current. So 5 into 24 by 25, 5, so 24 by 5 volts. This becomes క్యాల్కులేటర్లో పెట్టండి. క్యాల్కులేటర్లో పెడితే కొంతమంది తప్పని చెప్తారు 4.8 volts. ఓకే, I took this as positive, this is negative. So next, the voltage across this by only the current flow. కరెంట్ సోర్స్ వేసినప్పుడు వోల్టేజ్ సోర్స్ తీసేయాలి కదా, కాబట్టి షార్ట్ చేస్తాం. దిస్ ఈస్ AB 16, 10, 10, 5. సో ఇప్పుడు మనకి ఈ వోల్టేజ్ కావాలంటే ద వోల్టేజ్ డ్రాప్ అక్రాస్ దిస్ వన్ అండ్ దిస్ వన్, దట్ బికమ్స్ ద వోల్టేజ్ డ్రాప్ అక్రాస్ దిస్. సో ఏమి చేస్తాం, లేదనుకుంటే కరెంట్ ఇలా వచ్చింది, ఇలా వెళ్తుంది. అంటే ఈక్వలెంట్ సర్క్యూట్ నువ్వు గీసినట్టయితే yes 10, these two are in series, this is 10, this 63 amperes. So these two are in series. Then this is 15, if this 15 is in parallel with 10. So ఓకే, ఓపెన్ చేద్దాం. మనకి వోల్టేజ్ ఇక్కడ అయితే you can then apply Thevenin theorem, KVL. సో ఇక్కడ కావాలంటే ద కరెంట్ ఫ్లో ఇన్ దిస్ ఇస్ 3 amperes. సో నెక్స్ట్ ఇది కావాలి అంటే ఇందులో కరెంట్ కావాలి. ఇప్పుడు కరెంట్ ఇలా ఫ్లో అవుతుంది కాబట్టి ఇది ప్లస్ మైనస్, అగైన్ కరెంటు ఇలా వచ్చి ఇలా ఫ్లో అవుతుంది, అంటే ఇలా ఫ్లో అయ్యి ఇక్కడికి వస్తుంది కదా. ఇది ఓపెన్ కాబట్టి ఇది ఈ టెర్మినల్ మనం కన్సిడర్ చేయం. ఇలాగ వస్తుంది కాబట్టి, ఎందుకంటే కరెంట్ ఇలా వచ్చి ఇలాగా వస్తుంది కాబట్టి ఇలా కలిసిపోతుంది కాబట్టి ఇది ప్లస్ మైనస్. నౌ ద కరెంట్ ఇన్ దిస్ ఇస్, let I 15 is 3 into అదర్ రెసిస్టెన్స్. ప్యారల్గా ఉంది కదా, ఈ రెండు ప్యారల్ కదా, దీనికి అదర్ రెసిస్టెన్స్ 10 బై టోటల్ ఇది ప్లస్ ఇది ఎంత అవుద్ది 25. సో 30 by 25 amperes. The voltage across this is the current flow in this in 5 ohms also. So the voltage across this is V5 equal to 5 into 30 by 25. So 5s are 6 are 6 volts వచ్చింది. అంటే ఇదేమో 6 volts, ఇక్కడ 3 into 16 becomes 3 into 16 48 volts. So this is here, this is 48 volts. Now apply KVL. Now I assumed it as a positive, this is negative because this I assumed it as a higher potential. So if you start from here, then you're crossing positive. Here you're also crossing positive. Okay. So 48 plus 6 plus VAB equal 0. From this VAB equal to minus 54 volts. This is 54. The VA double dash, VAB double dash. This is minus 54. VAB dash is 4.8 volts. Therefore VAB equal to VAB dash plus VAB double dash. What is VAB double dash? 4.8 plus minus 54. So this becomes 54 minus 4.8, 49.2 volts. This is negative. Okay. Minus 49.2 volts. This is VTH. What about RTH? I am arranging this. Now for finding RTH, remove all the sources. If it is a current source, isolate, open it. If it is a battery or voltage source, looking from this 16, this is 10, this is 10, this is 5. Now these two are parallel again, sorry, these two are series and parallel. So 10 plus 10, 20 parallel 5, 20 into 5 by 25, 4 ohms. Now the entire parallel combination is in series with 16. So this is RTH is 16 plus 4, 20 ohms. So from the given option, C is the correct answer. 49.2 volts, 20 ohms. This way you can find the Thevenin equivalent and you can solve the 53 question from the ESE. Now the next question is this one. What is the maximum power that can be delivered to the variable resistance R in the circuit? See, if you want to find Thevenin equivalent, maximum power, first find the Thevenin equivalent, because Thevenin equivalent circuit is like this. This is our variable resistance, this is RTH, this is VTH. So if you want to find the maximum power, find the first Thevenin equivalent. So now for that, remove this resistance. So $60 volts, 25, 10, 5, 20. Find the voltage across this terminal. Let this is positive, this is negative. See, this branch and this branch is in parallel and also in parallel with the voltage source. So what is the current and what is the current in this? Let this is I1, let this is I2. I1 is 60 by 30, this is 2 amperes. I2 is 60 by 30, this is also 2 amperes. So voltage drop across 10. This is positive, this is negative, this is positive, this is negative. Now V10 is 10 into 2, 20 volts. V25 is 25 into 2, 50 volts. Now apply KVL. So if you start from here, then you are crossing negative, minus 20 minus VTH plus 50 equal to 0. So VTH is 30 volts. Now what is RTH? Remove this battery, that is short this battery, and find the resistance across these two terminals. Then for that, actually this is the position, so I keep this short circuit or this loop in middle of that. So now I want to find the resistance across AB. This is 10, this is 20, this is 25, this is 5. So see, from this, these two are parallel, these two are parallel. So 20 into 10 by 30, 20 by 3, 25 into 5 by 30, so 25 by 6. Now RTH is equal to 20 by 3 plus 25 by 6. So 40 plus 25 by 6, 65 by 6 ohms. So RTH is how much? Calculate తీయండి, అలవాటు అయిపోయిన తర్వాత ఇంకేం చేయను. 65 divided by 6, 10.833 ohms. Now this is RTH, this is VTH. What is the condition for maximum power transfer? RTH is the same as RL, then only the power, the maximum power will be delivered on the load, in the load. So this is same as this one. Therefore I in that current is VTH by 2 RTH. What is VTH? VTH is 30 by 2 into RTH, 10.83. So 30 divided by 2 divided by 10.833. So 1.384 or 386 amperes. This is the current flow in this circuit. Now, what is P max I square RTH or R? What is I? 1.384 or 385 square into RTH. RTH is 10.8333. So, now we get 1.385 into 1.385 into 10.833. This is 20.78 watts. This is 20.78. So the given answers are 15.77 watts, 18.77 watts, 19.77 watts, 20.77 watts. So this is the answer for this question. Now the another question is 55. Consider the following statements regarding the initial conditions for the inductor and capacitor. Initial conditions inductor capacitor. It's a very simple. It's a theory bit, but you must go through it thoroughly. First one is there is no current flow through the inductor at a t equal to 0 minus. Ante before switching action, no current in the inductor flow. Inductor current flow in the inductor. Then the inductor will act as an open circuit at t equal to 0 plus. Yes, this is correct. Whenever the switching actions happened in the no energizing of the inductor previously, then the inductor will act as a open. This is correct. Second one is if there is no voltage across the capacitor at t equal to 0 minus before switching action, the capacitor will act as an open circuit. This is wrong. Short circuit. Capacitor will act as a short circuit when the switching action. This is wrong. If a current of value I naught flow through the inductor at t equal to 0 minus, already current is flowing through the inductor before switching action. The inductor can regarding as a current source of I naught amperes at t equal to 0 plus. Which of the above statement is correct? This one is correct and this one is correct. This is wrong. See, in the switching action, when switch is closed suddenly, then inductor will act as a open. Suppose if switch is closed suddenly, capacitor will act as a short. Suppose previously current I naught is flowing, then this will act as inductor will act as a open, but the current source will be as it is. So the statements 1 and 3 are correct. This is wrong. Okay, I think you can understand easily. So if you go through in a systematic way and you must feel it as your own, then any exam is very simple. Feel it is yours. Okay.